Hello and welcome to this video on partial fractions. Partial fractions can be useful, especially for integration when it comes to a difficult function. It might sometimes be useful to be able to break this function up and then be able to integrate it. Let's begin this video on partial fractions. This is an example of an expression that can be broken up into smaller additions. It's usually expressed in this form. Some sort of constant a over the first bracket plus some other constant b over the second bracket. We can show how we got to this expression by including this expression. From this expression, I'm just going to use the numerator ax plus 3 plus b times x minus 2 must be equal to 1, which is the numerator of our beginning function or beginning expression. I'm going to multiply this out. Then I'll group all of the like terms, so in this case group the x terms together. Now I'm going to compare coefficients from the left-hand side and the right-hand side, and hopefully we should come up with some simultaneous equations which, if solved, could then give us the a and b values. On the left-hand side, for the x variables, we have a plus b. And on the right-hand side, we do not have an x, so they must equal 0. On the left-hand side, we have 3a minus 2b. And on the right-hand side, we have the value 1. We can use these simultaneous equations to find the values of a and b. I will times the top simultaneous equation by 3. Then I'm going to take them away from each other. So 3a minus 3a is 0. 3b minus 2b ends up being 5b. And 0 take away 1 is minus 1. The value of b is minus 1 over 5. We can see from the simultaneous equation a plus b equals 0 that for this to be true, then a must equal 1 over 5. Now we know the values of a and b, we can sub them into this expression here, and this will be our partial fraction. So a is 1 over 5, and b is minus 1 over 5. And that is our partial fraction. Let's do another example. In this example, we have x as the numerator and x plus 4 times x plus 1 in brackets as the denominator. Again, let's express this as a over x plus 4 plus b over x plus 1. If we find the expression for the numerator, multiply this out, group like terms, now we can compare the coefficients. On the left-hand side, the x terms are a plus b, and on the right-hand side, its coefficient is 1. On the left-hand side, we have a plus 4b, and that must equal to 0 as there is no term there. Again, solve the simultaneous equations. Here I'm going to take them away from each other. So a minus a is 0, b minus 4b is minus 3b, and 1 minus 0 is 1. Therefore b is minus a third. Again, we know from the first simultaneous equation a plus b must equal to 1. So if we substitute the value of minus a third into this, we can find out the value for a. So a must be 4/3. Now that we have the values, we can put them back into this expression, and this will give us our partial fraction. So a is 4/3, and b is minus a third. We'll do one last example. For this expression, we've got an x squared term plus an x, but we can express this as a over x plus 4 plus b over x plus 1, going straight to what the numerator would be. Times the left-hand side out. Group the like terms. And now we can compare coefficients. The left-hand side has 0 x squared coefficients, and so we can ignore the x squared. The left-hand side does have an x coefficient, which is a plus b, and on the right-hand side, this is equal to 6. And then we are left with a plus 4b equal to 4. Now we can solve the simultaneous equations. I'm going to take them away from each other. A minus a is 0, 1b minus 4b minus 3b, and 6 minus 4 is 2. So b is minus 2/3. Now if we substitute this value into the first simultaneous equation, we can get the value for a. So a minus 2/3 equals 6. Therefore a is equal to, so 6, if we rewrite that in terms of thirds, that's 18 over 3, plus 2 over 3, that will become 20 over 3. Now that we've got the values, sub them back in, and this will give us our partial fraction. That's it for the video today. If you have any questions, do please put them in the comments below. If you liked the video, if it was helpful, please like and subscribe and tell your friends about this. And I hope you have a good day.